It's 1:00 p.m. Central Standard Time, February the 3rd, on this beautiful, supposed to be winter day. I would say the spring has got here early, but I understand next week winter's going to come back. Now, we want to say a special welcome at the Dallas ISD STEM Environmental Education Center to College Hills School at College Station ISD, Withers from Dallas ISD, Marsalis from Dallas ISD, Pleasant Run from Lancaster ISD, which my children attended several years ago, Purefoy from Frisco ISD, San Jacinto, Dallas ISD, and Oren Roberts, Dallas ISD. Thank you again for joining us on this beautiful day. I hope you enjoy the program. If you're watching and you haven't signed up, please go to www.tiny.cc/EEC register and sign up, please. This is just for our attendance records. Appreciate if you'd do that. Today, we're going to discuss weather. During this virtual field trip, students will discover that there are recognizable patterns in the natural world and among objects in the sky. Students will observe and compare day-to-day weather changes in different locations at the same time. Ms. Ramirez is going to tell you about measuring, recording weather, and graphing the weather. Ms. Nash will talk about related choices due to the weather. Mr. Monroe is going to tell you about many different tools we use to predict the weather and study the weather. Ms. Fuller will tell you how to make your own weather station. And we have a special treat today. We have a guest meteorologist named Mr. Wesley. This is a virtual field trip, so you can't ask questions verbally. However, you can go to www.tiny.cc/EEC /question/answer and send in your questions, and we'll do the very best that we can to answer them for you. Now I'm going to stop sharing my screen. And Ms. Ramirez is going to tell you about measuring and recording and graphing the weather.
Hello, my name is Ms. Ramirez, and we're going to be observing, recording, and graphing weather at the Environmental Center. So let me go ahead and get my screen share started so we can view our presentation. And since y'all are not able to visit us, I actually took some video of weather that we have experienced out here at the center. So what we're going to do, we're going to go on a virtual weather walk for a quick 1-minute movement break. So this would be a nice time. If you would like to join in, feel free to stand, push your chair in, and we're gonna walk in place as you observe the weather here at the Environmental Center virtually. So as you guys are enjoying the video, be thinking about how can you describe the weather that you're seeing. So I'm gonna go ahead and start the video and put it in full screen. Also on the bottom of the screen on the lower right, I have a walk box if you would like to walk along as you're enjoying the weather scenes. So we experienced quite a few different kinds of weather at the center over the past 2 weeks. Some windy weather, and how do you think we can tell it's windy? And for those that are walking along, I have my windmill stretching arms going around. Hopefully you guys are able to notice that windsock was moving rather quickly. We saw the trees moving, and look at the flags. The flags are also moving from the wind. This was a rather rainy day. That's our pond behind our facility. This is the hidden lake across the street in the Post Oak Preserve. So it was a beautiful sunny day that day. So now we're gonna go ahead and stop our little video and move on to our next slide. So y'all can, if y'all were joining us for our walk, you guys can go ahead and take a seat, and then we'll move over to our next slide. So what I ended up doing was I recorded the weather information at the center. So I created a weather log very similar to what you see here on the right. I wrote down the date, the temperature, cloud coverage, precipitation, and the wind. So those were some of the things that I was looking for throughout the day as I was recording. So let's take an example on Monday, January 25th. So take a moment, Observe some of the weather that you see in the pictures. Think about what are the weather tools that are presented and what do those weather tools tell us. Also see if you can read and measure using those weather tools in the picture. Now I'm going to go through these rather quickly, so if you need time, feel free to pause the video stream for more observation time. So in our first picture, we have hail. So we had a really bad thunderstorm, lots of lightning and thunder, some crazy hard rain, and we actually got some hail. We also see in this picture, we have a cloudy, dreary sky. And then we have this special weather tool called a rain gauge, and that rain gauge tells us the amount of precipitation. So see if you can determine how much rain fell this day using the rain gauge. Now, if I were to record this weather information in a data chart, what do you think it would look like and how would you record it? Now that's Monday morning. Now, Monday afternoon, that same day looked totally different. So again, make some quick weather observations. What do you guys notice about the type of weather that we had in the afternoon? And think about, can you read and measure using the weather tool that's provided? So let's take a look at this beautiful picture here. The afternoon turned to be a wonderful, beautiful day, nice blue skies. We have these thin, wispy clouds. They kind of remind me of like a white mustache. Those are called cirrus clouds. And then look at our thermometer over here. The thermometer that day read 70 degrees. So that afternoon, it got quite warm. So if I were to record weather information for Monday, I actually did it twice. I did it once in the morning and once in the afternoon because the weather was totally different. So in the morning, it was cool, cloudy. We had rain and hail, and it was breezy. In the afternoon, it got warm. We had clear skies, and we didn't have any more precipitation. So that tells us that weather can change not only from day to day, but also within the day itself. Now let's take a look at January 26th. Make some quick weather observations. What do you guys notice? What do those weather instruments tell you guys? And again, you can pause the video to give yourself more time to observe and discuss. So in this picture over here, we see a nice bright sun. It was a sunny day. I didn't really see any clouds that day. Take a look at our windsock. It is not moving. It's totally up and down. It's vertical. So it was a very calm day, not a lot of wind. Take a look at our rain gauge. There's no rain in it, so we had no precipitation. And then take a look at our thermometer on this side. So we have, it was probably about 50 degrees Fahrenheit, so kind of cool, definitely cooler than it was the previous day when it got up to 70. So if I were to record this information in my data chart, this is what it would look like. Cool weather, sunny, cloud coverage, no precipitation, and calm winds. And then my last journaling day was Wednesday. So again, take a quick moment to make some observations about what you guys are seeing and what those weather tools are telling us. And again, pause the video if you need to. This first picture right here, we had some cool looking clouds that day. Those are cumulus clouds. They are the ones that kind of look like fluffy white cotton balls. And look at our windsock. Look how it changed position. It is now completely horizontal and it was moving like crazy in that wind. And then here's our rain gauge again. Notice there's no rain that day either. And then here's our thermometer. Our temperature dropped again. So now it's about 44 degrees Fahrenheit, so rather on the chilly side. So you can see our temperature kind of went up and down from the 70s all the way down back to the 40s again. So if I were to record my weather information for that day, this is what I came up with. It was cold, sunny, we had no rain, and it was rather windy that day. Now, one more thing that we're going to talk about is comparing our own local weather to weather in other places. So I chose Lima, Peru. So how does DFW weather compare to weather in Lima, Peru? So here we are in Texas over here, and then here is Peru in South America. So what I did, I used a nice little website called weather.com, and it gives you the weather information for your new location. So here is our weather information for Seagoville, Texas for the week that I recorded it. And here is weather information for Lima, Peru for that same week. So make some quick observations, compare and contrast the weather in these two locations, and what do you notice? So again, you can take time to pause the video if you need more discussion time, but take a look at Peru. Right away, I noticed that the temperatures are much warmer in Peru right now than they are where we live in Seagoville, Texas. I also noticed one of the things that stood out was that Lima, Peru had a lot of cloudy days. In fact, this is their rainy season, and January typically is the wettest month for Peru. So places all over the world experience different weather. So just because we're experiencing this weather here doesn't mean everyone else in the world is. So something you guys can do, I have a challenge for y'all. I would like for y'all to observe and record weather data for your area for 1 week. And then pick your dream vacation spot, record weather data for that area for the same week. And again, you can use weather.com, and then compare weather changes in both of those locations. So I'm going to stop our screen share, and that's all I have for you guys on weather. We're going to go ahead and pass it back to Dr. Gorman, and he's going to answer any questions.
Thank you, Ms. Ramirez. What an interesting idea is to compare your town to a land far away and see what the difference is, or if maybe they're the same. Your question was, why is it important to record the weather? And it says weather recording is important for recognizing local climate trends and forecasting. That way you can kind of forecast, get an idea of maybe what clothes you want to wear, or maybe what activities you want to participate in. And now Ms. Nash is going to tell us about the importance of using weather to make our choices.
Hello, welcome to my classroom. This is how I was dressed when I left the house this morning. I had my gloves on, my hat on, my bufanda, my vest, but I don't move now. Once I came in the building, it wasn't cold anymore. Because we have buildings, houses, and other buildings that keep us warm in the winter and cool in the summer. If it's raining outside, I've got my raincoat. If it's really hot, I can take my fan with me. But basically, we have different clothes for different seasons, and we have our houses to keep us warm. But the thing I thought was interesting to think about is the fact that the animals don't have those things. So let's think about how some of our animal friends adapt to changing weather and seasons. And day before yesterday was Groundhog Day. You may have heard about it. We don't have any groundhogs here in Texas, but they're quite common in other parts of the country. It's a kind of a large, like a ground squirrel, but big, with a short tail. And the story is that if it comes out of hibernation and sees its shadow, we'll have 6 more weeks of winter. That's not true, but the funny thing. But poor groundhog, he got woken up. He was hibernating. So hibernating is a really great way to adapt to really cold, snowy areas if you don't have any food to eat. So groundhogs eat plants that die or get buried under snow in the winter. So they have a burrow underground where the temperature is constant, not really, really cold, pretty cold, but not freezing. So they go down, they eat and eat and get fat, and then they go down underground and there they hibernate. Their body temperature drops, their breathing slows down, their heart rate slows way down, and they survive until spring. And then they come out and they're skinny and very hungry. Now people and many other animals don't hibernate in the winter. So how do they survive? So our Arctic fox there has that thick, fuzzy coat to keep warm. We can wear coats. Also, we don't grow them ourselves, but we wear them to stay warm in the winter. But even with a really great coat on, we wouldn't be very comfy taking a nap in the snow, I don't think. We gather food in the summer and fall, and we preserve it. We dry it or we can it so we have it later. And animals do the same thing if you think about it. So the squirrel hides acorns underground or in a tree. And there's a really cool bird called the acorn woodpecker that pokes holes in a tree and then sticks an acorn in them to eat during the winter. Birds, because they can fly, can migrate or leave and go somewhere else when the seasons change. So our hummingbird is here in the spring and summer and fall. But then when winter comes, there's no more flowers. So they go to Mexico and Central America. But we also have birds that come here for the winter. Like if you go down to White Rock Lake right now, there are tons of pelicans there because their lakes up north freeze. They're iced. So they come here where the water doesn't freeze and they spend the winter with us. They're so cool to watch. So we people, because we're so clever, we've learned to survive in all kinds of places, really cold places like the Arctic in the igloo there, or in the steppes of Asia and Europe. And of course, fire is another way to survive in the cold. Here in Texas, most of our survival happens in the summer. Can we survive another hot, hot summer? And the best way to do that is to go swimming. So we can go swimming and cool off, and so can all these other animals that also like to swim. So Sarah, and I'm going to introduce you to a little friend of mine who would also be hibernating if he were not living inside. And that's my friend Red. So Red is a snake or reptile, and they're cold-blooded. That means their body temperature changes with the environment. If I put a sweater on Red, it does not help. So he has to hibernate if he were living outside. Because he's a reptile. So different kinds of animals adapt to the seasons in different ways. And what I'd like you to do is to pick an animal, choose an animal that you think is interesting, and see if you can do some research and find out how it adapts to different seasons. So some animals, like a grasshopper, their whole life might be in 1 year. And so each season of the year would be another stage in their life cycle. So lots of fun things to learn about animals and their adaptations to seasons. And you can compare them to us, how we adapt to changes in weather and seasons, and how the other animals do. So thank you. And if you have any questions, I'm sure Dr. Gorman would be glad to answer.
Yes, Ms. Nash, thank you for that. And we did definitely have a question. And did Phil in Pennsylvania see his shadow yesterday? And I happened to be watching that for some reason yesterday morning while I was getting ready to come to work. And in a fierce snowstorm, Phil actually did see his shadow. So according to local legend now, we're going to have 6 more weeks of winter. And now we're going to hear Mr. Monroe tell you all about weather tools.
Good afternoon, students. My name is Mr. Monroe, and we're going to be looking at a variety of tools that are used by very special scientists called meteorologists. Now, meteorologists, they actually study a very special science called meteorology. And it is the study of the air bubble, which we call our atmosphere, that surrounds our planet, the planet Earth. Whether you know it or not, there are 3 major components that make our weather here on Earth: the sun, the water that we have on the surface of our planet and in our atmosphere, and then something that is invisible, that is all around us. Of course, we can't feel it, we can't grab it. The only time we know it's around is if it's moving. And we call that air, which I'm referring to, we call it wind when it is moving. So let's start out with the sun. The sun is the ultimate source of light and heat energy for our planet. It warms up the surface of our planet, and it also warms up the air that surrounds us. Now, because our planet is in a sphere, we get a lot of uneven heating, which causes a variety of different weather patterns. Now, students, listen. Meteorologists use a very special instrument called a thermometer to measure how hot or cold the air is around that thermometer. It's a very important measurement because it also helps that meteorologist kind of determine or be able to predict or forecast the weather for the future, which is very important to all of us. Now, a thermometer was used by Ms. Ramirez to record some data. She showed you one that looked similar to this. She also showed you one that was in a circular shape that looked similar to this. And the way that thermometer works, inside the thermometer, I'm using a demonstrating thermometer here, there's a tube that has a red fluid in it. If the temperature goes up or it starts to warm up, the fluid travels up. If it starts to cool down, then the fluid travels down. That's the way it works. Now, on a thermometer, you will see two different sets of numbers. One on one side, a set of numbers on the other side. They're actually representing two different types of units of measurement. On this side, we have what we call the customary measurement, which is in Fahrenheit. On this side, we have what we call the metric system, which is in Celsius, all right? So a thermometer is used to measure how hot or cold the air is around it. One of the other components that make our weather is the water that we find on our surface of our planet. You know, most of our planet is covered by water, but we also have water that's in the atmosphere. If you haven't, you will study how water is replenished on our planet. It's called the water cycle. And a lot of that cycle, the processes happen in the atmosphere. When it falls back to the earth, we call it precipitation. Now, Ms. Ramirez showed you a rain gauge. That rain gauge looks something like this. This instrument would be placed out in the open. As precipitation fell, it would collect in the top, moving down the tube, and in the bottom of the tube is a flotation device which would rise according to the level of water in the rain gauge. And at that time, you could take a measurement. Now, not all rain gauges look like that. Here I have one that is part of a mini weather station that simply would be put out in the open, and this is the rain gauge part of it. One side is in inches, the other side is in centimeters. The inch side, guess what? That's the customary measurement. The centimeter side, that is the metric measurement units that are used in the metric system. Now, students, it would be very important that if you had a rain gauge and we got precipitation on a day, after you took your measurement, it would be good to empty the water out, because if you get another rain day, you don't want both days to be combined. You wouldn't get a very accurate measurement, would you? Now, what about snowfall? It is considered to be precipitation also. Do you think maybe using this rain gauge would give you an accurate measurement of how much snow fell? Well, probably not. You know, the easy way probably would be for you to go out once the snow stopped falling and just take a simple ruler and stick it down in the snow and take a measurement of how deep the snow is. And that way you would know how many inches of snow had fallen. Even on the backside of a ruler, you will find the centimeter side also. Now let's move on to the other part, the invisible part that we don't see around us unless it's moving, air. Air is a very important factor or component in our weather patterns, in our weather system. You know, knowing the direction that the air or wind is blowing from is very important for meteorologists to be able to predict and forecast the weather. Take, for example, this weekend, it is predicted or forecasted that we're going to get cooler, even downright cold next week, simply because they have determined that we're going to get some of the air from the Arctic Circle. It is called the Arctic Vortex, and it's headed this way. Now, we won't get all of it, but that is coming from the north. Now, when we get wind, it's good to know what direction the wind is coming from. An instrument that is used to find that out is called a wind vane. Here I have a wind vane right here. Now, long ago, they had wind vanes that had the same information on it, but in the center, instead of having an arrow, there would be a rooster. Now, you see there's an N here, a W here, an S here, and an E here. N stands for north, W stands for west, S stands for south, and the E stands for east. And as the wind blows, this arrow with a rudder on it is going to point the way that the wind is blowing from, okay? Most likely, if we're getting a north wind, it's going to be a little cooler, even cold. If we get a south wind, guess what? It's probably going to be a little warmer. Now, today is pretty nice. Tomorrow it's going to warm up. It has been my experience as I've studied weather, just before we get a cold front, we have warm days, okay? Now, as the wind blows, we also want to keep record of how fast that wind is blowing. And a good way to get that measurement is to use what we call an anemometer. What I'm holding in my hand is an example of an anemometer. As the wind blows, the wind catches in these little cups and the anemometer spins around. Attached to the anemometer is an electronic device that is going to give you readings of how fast the wind is blowing. And usually the measurement that is used is miles per hour. Now, Saturday we had a very strong wind. And of course, I didn't have an anemometer at my house, but I simply stepped outside in the back of my house and I looked across where there were some very large trees. And you know, those trees were doing a dance, weaving back and forth in the wind. And it let me know, boy, the winds were strong because those were some very big trees that were doing their dance. So wind speed is very important. I think the winds got up as high as somewhere between 40 to 45 miles per hour on Saturday. That's pretty strong. Of course, there are other instruments that are used too, simple instruments, such as a windsock. Miss Ramirez showed you guys a windsock. And the other day I went out to buy one because I wanted to show you all how a windsock works. I went to a store and you know what? Nobody in that store, when I asked for a windsock, they didn't know what I was talking about. I had a young man come up to me and he said, "Mister, is a windsock, is it a special sock that you could put on your foot?" I said, "Oh, no, it's not. It's an instrument used by meteorologists and even some people to figure out how strong the wind is and what direction the wind is coming from." So since I couldn't buy one, we have a very creative teacher on staff here who actually made a windsock for me to use in my demonstration. And here it is, okay? Now, I'm gonna furnish a little air as a wind source, and I want you to watch what happens when I imitate the wind blowing at a strong speed. Everybody watching? That windsock went straight out. What that indicates, because it's straight out, there's a very strong wind influencing the windsock. Now what happens when the windsock is not picking up a lot of air? It dies down and it goes vertical almost, okay? Now, where in the world would they use a windsock? Well, usually windsocks, you will see them, maybe some of those that are kind of decorative, you'll see them in somebody's yard or something, but most likely you're going to see a windsock at an airport. Even an airport where smaller planes are landing and taking off, they want to know how strong that wind is and what kind of influence it's going to have on that little plane when it takes off or when it tries to come in and land. Now, there are other tools that meteorologists use also, such as Doppler radar that can determine whether a severe thunderstorm or even tornadoes are headed that way. Also, weather balloons are released into the atmosphere with electronic devices to take readings. Even satellites that are orbiting around our planet, taking pictures of cloud formations and weather fronts. They use that. And they use that to chart another tool called a weather map. Now, one thing to remember, most weather patterns that are moving across the continental USA, because our country is located in the northern hemisphere, those weather patterns are going to move from the west to the east, with the exception of the Arctic vortex, which is going to come from the north. Now, we're not going to get all of that vortex, but we're going to get just enough of it to cool our temperatures down this coming weekend and week. Students, if any of you have any questions, I'm going to turn it back over to Dr. Gorman So he'll be able to answer those questions for you. I want you guys to have a good day the rest of the day. Goodbye.
Thank you, Mr. Monroe. And yes, the question is, what is the most common weather tool or weather instrument? I think we'll all agree that the thermometer means more to us than some of the other things. Now, if you're a pilot, then the wind direction and wind speed means something to you. If you're going to plant your garden to the round of rain and this, that, and the other. But the thermometer is most important, I do believe. And I have a assignment for you guys tonight. Tomorrow, when you get to school, I want you to be able to tell your teacher using a thermometer, or you can research it, what temperature does water freeze on the Fahrenheit side of the scale, and what temperature does water freeze on the Celsius side. Thank you again, Mr. Monroe. And now we're going to have Ms. Fuller tell us about weather stations.
Good morning or good afternoon. We're going to talk a little bit about weather stations. Weather stations are places that have devices that measure different aspects of the weather, the humidity, the wind speed, wind direction, temperature, all those barometric pressure, all those wonderful things we've been talking about. I'm going to share my screen with you. We're going to look at a couple of weather stations, and then we're going to talk about making our own. So let me get this started. And here we go. How to make your own weather station. Now you may say, Mrs. Fuller, I'm in primary and elementary school. I can't make a weather station. Well, we'll see. Okay, so it's fun to observe the weather and to record the weather. Remember, when you're in science, if you do an experiment or if you make an observation, no matter what the topic is, if you don't record it, it's like it didn't happen. So it's important for us to record our observations about the weather. Now let's look at three real big deal devices that are weather stations. The first one is the one on the left. It's yellow and it's in the ocean. It's called a buoy, and this buoy has lots of different weather measuring instruments on it, and it measures the weather on the ocean. The one in the middle is a satellite. It's in space above the Earth, and it can tell the weather for the whole planet. And this is the kind of satellite that takes the pictures of the hurricanes from miles above, where we can see the whole swirl of the cyclonic winds and see the eye in the middle. And then over there on the right-hand side, we see something that looks like a giant golf ball sitting on top of a building. That's a radar station. That kind of radar station is called a Doppler radar station, and they can tell you specifically where a storm is, what the wind speed is, whether it's got hail in it, how fast it's coming toward you. So it's a very wonderful weather station. Well, we can make our own weather station. Well, let's see how we can do that. First thing is you're going to need is a thermometer. Now, just about everybody who's spoken today has talked about temperature. Thermometer measures temperature. Look at this thermometer. On the left, it says degrees C, that means Celsius, and then the other side, degrees F, Fahrenheit. Celsius is a measurement of temperature in the metric system. The metric system is very easy, and it's all in tens. It's what the whole world uses, is the metric system to measure for science. The Fahrenheit system is part of the imperial system. Sometimes it's called the customary system, and that's a little bit different. And but we've got both sides on there for people who use the metric system and for people who use the imperial system. Now, let's look at the next thing we're going to need. A wind vane. Now, Mr. Monroe said something about a chicken being on top of a wind vane. We really like chickens here at the Environmental Center. The chicken, it could be a ship. Sometimes they have ships on them. Sometimes a cow. So it doesn't have to be a chicken. There are a lot of different things that can be on top of a wind vane or weather vane, and it indicates wind direction. We name the wind the direction it comes from. So the wind vane will turn and face the direction the wind is coming from. So when we get this Arctic blast, that wind's going to be coming from the north, right? The next one is a rain gauge. This measures the amount of rain you get every day. Because it measures it for every day, at the end of the day, after you make your recording of your observation, you have to empty it so that the rain doesn't accumulate. All right, and the next one is a windsock. Now, the windsock, that red and white one over there on the left, that's the kind you would see at a small airport like the Executive Airport in Oak Cliff. The picture on the right is just a picture of flags outside of school, and you can see that the wind is blowing so strong that they stand straight out. They're horizontal and full of wind, and that's a very strong wind that's able to do that. So let me take away my share of my screen here, and we're going to look at some different things. Now, we can't make a thermometer, but you can buy one. They're very inexpensive, and it's just a little glass tube with some alcohol in it that's on a little piece of aluminum. You have to hang it in the shade. It can't be in the sun. If you hang it where the sun gets on it, you're measuring the heat of the sun, not the heat of the air. And that's what this is for, is to measure the heat of the air. So remember, if you're going to hang it, put it on the side of a shed or the patio or the garage, someplace outside where it's in the shade all the time. Now, the next one is a nice little rain gauge. And I made this out of a 2-liter soda water bottle. So cut the top off. You'll need help with that from mom or dad. And that'll be the funnel that funnels the water into the rain gauge. Now, I put a piece of duct tape here. Oh, before that, I filled the bottom with plaster of Paris. That's to make it heavy so that when the wind blows, it doesn't topple over and all our rain gets out on the ground. Now, on this piece of duct tape, on one side, I put the measurements for customary or imperial measurement. This is inches. So when you listen to the weatherman on Channel 5, he'll say, we got 1.5 inches of rain. That's this side right here. People that use the metric system would say centimeters. So this is marked off in centimeters. So we've got a level surface inside because of the plaster of Paris. It's real heavy. And then you take the top and invert it, and it becomes the funnel that funnels the water inside. Remember, you have to empty it every day after you record your observation. Now, the next one, this is an easy way to make a windsock. You just take a stick. This is just a plain old stick. And I took one of those grocery bags and cut it into strips. And this just took regular old tape, taped it on there. So look at this, it's so light, it responds to the wind really easily. So there's a breeze, there's a moderate wind. And then if I took a real big breath, maybe we could have a strong breeze or a strong wind like we saw with the flags. So that's an easy way to do that. The last thing I'm going to show you really quickly is a weather vane or wind vane. And I put a piece of Play-Doh on a clipboard, and then I stuck a pencil in it. It's got to have a good eraser because I got to stick a pin in the top. And then I took a piece of cardboard and cut it, traced around a CD and put the CD tracing on there. And I put north, south, east, and west on here. And then I have a little tiny compass and I put it there and it tells me north is that way. So I'm gonna put north right here. And then I took a drinking straw and made a slit and put the tail of the arrow here and the point of the arrow here, and then attached it with a pin so that it can move as the wind blows on it. Now, the arrow is gonna point to where the wind is coming from, and that's where we name the wind. We name the wind the direction it's coming from. The pointed part of the arrow has less resistance than the tail part, so that's why this points toward the area where the wind is coming from. That's all the time I have. If you have any more questions about making your own weather station. Just remember, when you make your observation, you have to record what you observe. Thank you so much. Dr. Gorman will help you with any questions.
Thank you, Ms. Fuller. How interesting, be able to make your own weather station. And using the 2-liter bottle was pretty unique, because we all have some of those in our refrigerator, or most of us do. And the question is, does it matter how big or round the rain gauge is? And the answer to that is no, as long as it is straight up and down. You don't want where it's narrow at the top and wide at the bottom. You want them straight up and down. So you can use any size bottle to make your rain gauge. And now Mr. Broughton's going to introduce our guest speaker, Mr. Wesley.
Thank you, Dr. Gorman. So we have learned all sorts of things about the weather now. And what can you do with all of that knowledge? Well, you could grow up and become a meteorologist. We are about to meet a meteorologist. His name is Mr. Wesley, and he works at the Texas Commission on Environmental Quality. So if you would like to know more about where he works, this is their website. It's tceq.texas.gov. And once you get there, you can learn all about what they do. And they do study air, land, and water, which is what you study in the 3rd grade. So that would be good to check out. And part of TCEQ is takecareoftexas.org. That is a website that teaches kids and adults how to conserve water, keep water clean, keep our air clean, reduce waste. There's all kinds of more information on there. There's information for kids, information for teachers. A lot of it you can request for free, maybe even all of it. And it's a great resource to use. And he works with Take Care of Texas. But now we're going to meet Mr. Wesley, and he's going to tell us about what he does.
Hi, my name is Wesley, and I'm a meteorologist with the Texas Commission on Environmental Quality, but we call it the TCEQ for short. The TCEQ is a state agency that protects our environment and makes sure our air, water, and land is protected from pollutants. We also teach Texans about how they can help keep Texas's environment clean. I'm a meteorologist, but you might have heard the job called a weatherman. A meteorologist is a scientist who studies the weather and makes a forecast so we know what the weather will be in the future, which could be the weather tomorrow or the weather in a month. I'm a little different than the weatherman you see on TV. I track weather to study how it will affect our environment, as well as track how it affects air pollution. Sometimes pollutants can make our air dirty, which is especially important to know if you have asthma or other health problems. I make sure Texans know when the air is safe and clean to play outside. We use a colored chart to show how clean the air is. Green is the best and purple is the worst. Typically, we see orange ozone action days in the summertime when there's lots of sunshine and winds are light. They're also more common in big cities where there are more cars. To study the weather, I use weather measurements. Those are taken by air monitoring instruments and by air investigators. They work all across Texas, taking data with handheld monitors, air monitoring vehicles, and stationary air monitors. Their machines can sense lots of different things about the air that we can't see with just our eyes. They can tell us the temperature, pressure, humidity, and different types of invisible particles that are floating in our air. I use the information they gather to decide what that means for the weather and predict the amount of pollution that might be in the air. You can even monitor the weather yourself by using thermometers, rain gauges, anemometers, wind vanes, barometers, and hygrometers. Texas weather is very unique and special. Texas is very large, which means we have different types of weather across the state, even in a single day. It could be snowing in Amarillo while people in Corpus Christi are playing at the beach. In Texas, we have beaches and mountains, plains and hills, swamps and deserts, forests, and, well, you get the picture. Because of these different types of land, we see lots of different types of weather. Some of the types of weather we see in Texas are thunderstorms, hurricanes, tornadoes, snow, and fog. Texas has several different types of weather patterns that we see year after year in our state. Some common weather patterns we see are cold fronts, which are large areas of cold air that move across the state. Cold fronts cause some of the most interesting weather events that happen in Texas. When a cold front comes through, it's pushing the warm ocean air back out over the Gulf of Mexico and brings in the cold mountain air from the north. It happens all across the state as the cold front moves. This is why you might wear shorts one day, but the next day you might need a jacket. Another interesting weather event we see in Texas is hurricanes. They are very interesting to watch because we, as meteorologists, try to figure out where they are going to go. This is important so we can know whether or not it will cause problems for people who live close to the coast of Texas. It is important to know the difference between weather and climate. Weather is what is happening today and the next several days. Climate is the average weather over a longer period of time, like months and years. For example, even if the weather is rainy today, if it is the only time it has rained in the last 6 months, the overall climate during this time period would be dry. At the TCEQ, we track both weather and climate, since they are both very important. Thanks for taking the time to learn more about how the TCEQ helps you take care of Texas.
There we go. And I'd like to take a minute to thank the Texas Commission on Environmental Quality, and especially Mr. Wesley for sharing with us what he does as a meteorologist. And now I'm going to turn it back over to Dr. Gorman to see if there's any questions.
Thank you, Mr. Broughton, and a special thanks to Mr. Wesley. That was a very interesting program. And like Mr. Broughton said earlier, some of you may want to grow up to become a meteorologist and either be on television or work for TCEQ. Now I'm going to share my screen. During this virtual field trip, excuse me just a minute now, during this virtual field trip, students discovered that there are recognizable patterns in the natural world and among objects in the sky. Students observed and compared day-to-day weather changes in different locations at the same time. Ms. Ramirez covered measuring and recording weather and graphing the weather. Ms. Nash about choices that you make according to the weather. Mr. Monroe did an interesting program on the different tools. Ms. Fuller showed you how to make your own weather station. And our guest meteorologist, Mr. Wesley, told you about how to become a meteorologist. Thank you. How did we do? If you would, teachers, please fill out www.tiny.cc/EEC feedback. There's a short form there. Fill it out and send it back to us so we'll know what we're doing right or perhaps what we're not doing right. We'd like to look at those and make decisions for our future programs. Thank you again. I hope you have a great day. But more importantly, I hope you have a great life.